All 120-volt outlets in unfinished areas, including workshops, must be ground fault circuit interrupter, or GFCI, protected. Each GFCI receptacle must be individually protected and cannot daisy-chain protection to downstream outlets. The National Electrical Code, or NEC, does not explicitly require GFCI protection for 240-volt outlets. However, for increased safety and protection, it is strongly recommended to install GFCI protection for 240-volt receptacles in workshops. In the event of a ground fault in the equipment connected to the 240-volt outlet, a GFCI will trip and break the circuit, reducing the risk of electrical shock or fire. Some power tools and machinery can be sensitive to ground faults and may be damaged if not properly protected. A GFCI can help safeguard expensive equipment from damage. While not explicitly required by code, installing ground fault circuit interrupters on 240-volt outlets in workshops demonstrates a commitment to electrical safety and best practices. Regarding recommended GFCI options for 240-volt outlets, you have multiple choices. Firstly, you could install a dedicated 240-volt GFCI receptacle that is specifically designed for high-voltage applications. Secondly, you can use a 240-volt GFCI circuit breaker in the electrical panel to provide protection for the entire circuit. This option eliminates the need for a receptacle-mounted ground fault circuit interrupter. Ground fault circuit interrupter devices should be tested regularly to ensure proper operation. Always consult with a licensed electrician for specific electrical installations and safety considerations. Ground fault circuit interrupters are safety devices that protect people from electric shock. They work by monitoring the amount of current flowing through a circuit. If there is a difference of even a few milliamps between the amount of current flowing into the circuit and the amount of current flowing out, the GFCI will trip and cut off the power. This happens very quickly, in a fraction of a second, before a person can be seriously injured. Ground fault circuit interrupters are required by code in many areas of the home, including bathrooms, kitchens, and garages. They are also recommended for use in workshops and other areas where there is a risk of electric shock. There are two main types of ground fault circuit interrupters: receptacles and circuit breakers. Receptacle ground fault circuit interrupters are installed in place of standard electrical outlets. They have a test button and a reset button on the face of the receptacle. Circuit breaker ground fault circuit interrupters are installed in the electrical panel. They protect the entire circuit, including all of the outlets and appliances on that circuit. When choosing a ground fault circuit interrupter, it is important to select one that is rated for the voltage and amperage of the circuit. It is also important to choose a ground fault circuit interrupter that is listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. When installing a ground fault circuit interrupter, it is important to follow the manufacturer's instructions carefully. It is also important to test the ground fault circuit interrupter after it is installed to make sure that it is working properly. To test a receptacle ground fault circuit interrupter, plug a night light or other small appliance into the receptacle. Press the test button. The ground fault circuit interrupter should trip and cut off the power to the receptacle. If the ground fault circuit interrupter does not trip, it is not working properly and should be replaced. To test the circuit breaker ground fault circuit interrupter, turn on a light or other appliance on the circuit. Press the test button on the circuit breaker. The circuit breaker should trip and cut off the power to the circuit. If the circuit breaker does not trip, it is not working properly and should be replaced. Ground fault circuit interrupters are an important safety device that can help to protect people from electric shock. If you have any questions about ground fault circuit interrupters, please consult with a qualified electrician. Regarding the NEC, it is a set of standards for electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years. The NEC is not law, but it is widely adopted by state and local governments. It is also used by insurance companies and other organizations. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is divided into chapters, articles, and sections. Each section of the NEC contains specific requirements for electrical wiring and equipment. It is important to consult the NEC when planning and installing electrical wiring and equipment. The NEC can be a complex document, but it is essential for ensuring electrical safety. If you have any questions about the NEC, please consult with a qualified electrician or electrical engineer. Grounding is a critical aspect of electrical safety. It provides a path for fault current to flow back to the source, allowing the overcurrent protection device, such as a circuit breaker or fuse, to trip and to energize the circuit. Without proper grounding, a fault current could flow through a person who comes into contact with an energized part, resulting in electric shock. There are two main types of grounding: equipment grounding and system grounding. Equipment grounding connects the non-current carrying metal parts of electrical equipment, such as enclosures, raceways, and appliance frames, to the grounding electrode system. This provides a low impedance path for fault current to flow back to the source. System grounding connects the neutral conductor of an electrical system to the grounding electrode system. This helps to stabilize the voltage of the system and provides a path for fault current to flow back to the source. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes that are buried in the earth. The grounding electrodes are connected to the grounding busbar in the electrical panel. The grounding busbar is then connected to the neutral conductor of the electrical system. The size of the grounding conductors and the grounding electrodes must be in accordance with the NEC. It is important to ensure that all electrical equipment is properly grounded. This will help to protect people from electric shock and prevent damage to equipment. If you have any questions about grounding, please consult with a qualified electrician. Overcurrent protection is another essential aspect of electrical safety. It protects electrical circuits from damage caused by excessive current flow. Overcurrent can be caused by a short circuit, an overload, or a ground fault. Short circuits occur when there is a low resistance path between two conductors. This can cause a very high current to flow, which can damage the wiring and equipment. Overloads occur when too much current is flowing through a circuit. This can cause the wiring to overheat and potentially start a fire. Ground faults occur when current flows from a conductor to ground. This can happen if the insulation on a wire is damaged or if a piece of equipment is not properly grounded. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. Circuit breakers are automatic switches that trip and open the circuit when an overcurrent occurs. Fuses are devices that contain a thin strip of metal that melts and opens the circuit when an overcurrent occurs. The size of the overcurrent protection device must be properly matched to the ampacity of the circuit. The ampacity of a circuit is the maximum amount of current that the circuit can safely carry. It is important to ensure that all electrical circuits are properly protected by overcurrent protection devices. This will help to prevent damage to wiring and equipment and protect people from electric shock and fire. If you have any questions about overcurrent protection, please consult with a qualified electrician. When dealing with 240-volt circuits in a workshop, safety is paramount. Unlike 120-volt circuits, which are commonly used for lighting and small appliances, 240-volt circuits power larger equipment like welders, air compressors, and some power tools. Because of the higher voltage and amperage, the potential for electrical hazards is significantly increased. Firstly, always ensure that any 240-volt equipment is properly grounded. Grounding provides a safe path for electricity to flow in the event of a fault, preventing electric shock. Check the equipment's grounding plug and ensure that it is properly connected to a grounded outlet. Secondly, regularly inspect the cords and plugs of 240-volt equipment for any signs of damage, such as cracks, frays, or exposed wires. Damaged cords can create a serious shock hazard and should be replaced immediately. Thirdly, never overload a 240-volt circuit. Each circuit is designed to handle a specific amount of amperage. Overloading a circuit can cause the breaker to trip, or worse, it can lead to overheating and a potential fire. Be aware of the amperage requirements of each piece of equipment and avoid using multiple high amperage tools on the same circuit simultaneously. Fourthly, when working on or near 240-volt circuits, always energize the circuit at the breaker panel. Use a voltage tester to confirm that the circuit is indeed energized before starting any work. Fifthly, consider using a 240-volt ground fault circuit interrupter, or GFCI, breaker. While not always required by code, a GFCI breaker provides an additional layer of protection by detecting ground faults and immediately cutting off power to the circuit. This can be especially beneficial in a workshop environment where there is an increased risk of moisture and accidental contact with live circuits. Sixthly, ensure that all 240-volt outlets are properly installed and wired according to the NEC and local electrical codes. If you are not comfortable working with electrical wiring, hire a qualified electrician to do the work. Seventhly, use appropriately sized wiring for 240-volt circuits. The wire gauge must be capable of handling the amperage requirements of the equipment being powered. Undersized wiring can overheat and create a fire hazard. Eighthly, keep the workshop environment clean and dry. Moisture can conduct electricity and increase the risk of electric shock. Avoid using electrical equipment in damp or wet areas. Ninthly, always follow the manufacturer's instructions for operating 240-volt equipment. Use the equipment only for its intended purpose and avoid making any modifications that could compromise its safety. Tenthly, have a fire extinguisher readily available in the workshop in case of an electrical fire. Make sure the fire extinguisher is rated for electrical fires and that you know how to use it properly. Remembering, electricity can be dangerous if not handled properly. Taking these precautions can help you to stay safe when working with 240-volt circuits in a workshop. If you ever have any doubts or concerns about electrical safety, consult with a qualified electrician. They can provide guidance and assistance to ensure that your workshop is safe and up to code. In regards to electrical safety in a workshop setting, several key concepts and practices can significantly reduce the risk of accidents and injuries. Firstly, proper grounding is paramount. Ensure that all electrical tools, equipment, and outlets are correctly grounded to provide a safe path for fault currents. This prevents electric shock in case of insulation failure or other electrical faults. Secondly, ground fault circuit interrupters, or GFCIs, are essential safety devices, especially in damp or wet environments. GFCIs quickly detect ground faults and interrupt the power supply, preventing severe electric shock. Install GFCIs on all circuit serving outlets in the workshop, particularly those near water sources or on concrete floors. Thirdly, regular inspections of electrical cords and equipment are crucial. Look for frayed cords, damaged insulation, and loose connections. Replace any damaged cords or equipment immediately to prevent electrical hazards. Fourthly, use appropriately rated extension cords for the tools and equipment being used. Ensure that the extension cord's amperage rating is sufficient for the load to prevent overheating and potential fire hazards. Fifthly, avoid overloading circuits. Determine the amperage requirements of each tool and appliance and ensure that the total load on a circuit does not exceed its capacity. Use a circuit analyzer to check for proper wiring and load balance. Sixthly, proper lockout-tagout procedures should be followed when performing maintenance or repairs on electrical equipment. To energize the circuit, lock the disconnect switch in the off position and tag it to prevent accidental re-energization. Seventhly, maintain a clean and organized workshop environment. Keep electrical equipment and cords away from water, flammable materials, and clutter. Eighthly, provide adequate lighting in the workshop to improve visibility and reduce the risk of accidents. Use task lighting to illuminate specific work areas. Ninthly, wear appropriate personal protective equipment, or PPE, such as safety glasses, insulated gloves, and non-conductive footwear when working with electrical equipment. Tenthly, ensure that all electrical work is performed by qualified and licensed electricians. Do not attempt to perform electrical repairs or installations unless you have the necessary training and experience. Reviewing electrical safety is a shared responsibility. By following these guidelines and promoting a culture of safety in the workshop, you can significantly reduce the risk of electrical accidents and injuries. And remember, when working on anything, read and understand the manufacturer's instructions.